In this tutorial, I'll explain the concept of scales. The scales are classified something like this. The first one is a reduced scale. These reduced scales are used when the object size is larger than the drawing sheet size. For example, drawing the plans of buildings, or drawings of automobiles, etc. Here building size is obviously more than the size of the drawing sheet. In this case, all the dimensions of the building has to be reduced such that the dimensions of the building can be represented comfortably on the drawing sheet. So in this case, the reduced scales are used. The next one is full size scale. So full size scale is used when object size is equal to the size of the drawing sheet. In this case, no need to reduce or enlarge the dimensions of the object. The third one is enlarged scale. So this enlarged scale is used when the object size is smaller than the drawing sheet size. Best example is the injection needle. If you observe the injection needle, in the injection needle, a through hole will be there such that the fluid can pass through that hole onto the human body. So to represent that cross section area of the hole and the total diameter of the injection needle, certainly the dimensions has to increase. In that case, the enlarged scale is used. So these are the three different types of scales. The scale concept is required such that the object's dimensions can be easily represented on the drawing sheet. That is the purpose of taking scales. So now observe different ways of representing these scales. In this first one is representative fraction. Representative fraction, in short, we'll call this as RF. RF is the ratio of drawing length to actual length. So if drawing length is less, actual length is more, as in the case of buildings, then RF value will be less than 1. So it comes under reduced scale. If RF is 1, then it's a full size scale. Drawing length is more, actual length is less. That is the case of injection needle. In that case, RF will be more than 1. So this is the enlarged scale. The second one is engineer scale. In the engineer scale, the dimensions are represented as shown here. On the left hand side, we will take the drawing dimension. On the right hand side, we will take the actual dimension. So if you observe this, so here drawing dimension is less, actual dimension is more. So that is the reduced scale. Here actual dimension is more, drawing dimension is less. That is the enlarged scale. So this is the next method of representing scales. Graphical scale means this is directly drawn on the drawing sheet. So using this, so now observe what are the different types of graphical scales. First one is plane scale. This plane scale is used to represent up to 2 units or up to 1 decimal accuracy. So that is the purpose of going for plane scale. Suppose more than 2 units are required to show on the graphical scale, then go for diagonal scale. On the diagonal scale, 3 units can be represented, or you can represent up to 2 decimals. So that means suppose decimeters and centimeters can be plotted on the plane scale. Decimeters, centimeters and millimeters also can be represented on the diagonal scale. Next one is vernier scale. In vernier scale also you can represent 3 units. Next one is scale of chords. This scale of chords is used to mark or measure the angles without using the protractor. That is the main use of scale of chords. These are the various ways of representing scales, and these are the different types of graphical scales. So this general method consists of the following steps. First step is take the RF value if it is directly given in the problem, or find the RF value from the drawing length and actual length. If RF value is not given directly, then drawing length and actual length will be given in the problem, and using those two values we can easily find the RF value. That is the first step. Second step is read the problem carefully and extract the maximum length given in the problem. For a particular maximum length only, any graphical scale can be drawn. That's why extract the maximum length value given in the problem in the second step. In the third step, find the length of the scale in millimeters using the following relation. The length of the scale is equal to product of RF and maximum length. In the fourth step, you have to identify the units that are to be displayed on the scale. This information also will be given in the problem. Read the problem carefully and extract the units that are to be displayed on the scale. That is the fourth step. And the fifth step onwards, you have to start drawing. When you start drawing, the first step in drawing is the third step in this general procedure. So observe the third step. In the third step, you are finding length of the scale. So taking this length of the scale value as length, you have to start drawing the problem.